So before starting the session, let us fix our agenda. What we are going to be discussing is please for today. First, let us fix our agenda, guys, please. What we're going to be discussing. First, let us fix our agenda. This course is multi-cloud. DevOps with what? Multi. DevOps with what? Multi. Cloud. In this, we are going to be covered. So AWS administration, Azure administration, DevOps also. So these three we are going to be learning. But today, what is our agenda, guys, please? We're going to be discussing about what is DevOps. We're going to be discussing about what is DevOps. We are going to be discussing, guys, please. In tomorrow, what is a cloud? What is a multi-cloud? What is AWS? What is Azure? That we are going to be discussing by tomorrow class. So before starting the session, what exactly are course overview? What we are going to be? Let us try to understand, guys, please. So this course is DevOps with multi-cloud, Azure administration, AWS administration. We are going to be learning. So total duration of this course is 4.5 months class. Which are all the prerequisitions? Linux basics will be covered. Shell script will be covered. And no programming, Java, .NET, Python is not required. You require a laptop with these configurations. And who can join in this course? Freshers can join in this course. Experienced students can join in this course. Any non-IT students also can join in this course. And any graduate can also join in this course. Which are all the benefits, guys, please? Which are all the benefits, guys, please? Daily class recording videos after the payment. Via a Google Drive, you can access. From date of registration, you're going to be accessing up to 11 months. Resume preparation, interview question and answers, 4 live real-time projects, 80% of soft materials I'm going to be covered with. Our course starts with very basic level, finish with what advanced level. Each and every class is a practical implemented in front of you that you need to practice in your laptop. After completion of course, you will receive a course completed certificate from our institute. Daily 1 hour class, 7 a.m. to 8 a.m. So the classes are from Monday to Saturday. This is our admin number 9297 929777. Please call this number or else you can WhatsApp to at any point of time, guys, please. Yeah. So guys, please, this is an exactly our course overview. So do you have any question on top of it? Please be asking or else you can chat with me also. Fine. And before starting the session, I have a few questions. Let it be clarified with you. So what are the first question? What is an application? Second question, what is the server? Third question, what is SDLC? SDLC. So what is an application? The working software which is written any programming language we call as an application. What is an application? The working software which is written any programming language we call as an application. That application we're gonna be placed on server side. Once if it is placed on server side and we can access over internet as a website like Flipkart or Amazon, book my show. Sir, what about SDLC? SDLC is a software development life cycle. In SDLC, we have several stages and several phases. Several stages and several phases. In SDLC, we have analysis, design, implementation, testing, deploy, and maintenance. We have several stages and several phases, yes, please. For example, if you want to do business internet like Flipkart or Amazon, what are the first step, guys, please? We need to get the information from the client. How exactly the login page, registration page, payment gateway, each and everything will be gathered. Based on gathering information, our architects will be designed. Our architects will be designed. Once if it is designed, so our developers will implement by using Java.NET Python or developers will implement. Once if it is an implement, it's going to be testing by verifying by functionality by testers, whether it is login page is working or not, registration page is working or not. Our testers will be verified. Once if it is verified, we're going to be deploying our applications on hundreds of servers. Placing our websites on hundreds of servers, we calling as what? Deployment. Once if it is deployed and we can access our internet as a website. And whether it is working or not, we are gonna be, once if it is deployed, we can access our internet as a website like Flipkart or Amazon, book my show. But whether it is working or not, we're gonna be monitor and maintenance. This entire process which you are calling as what? Software development lifecycle. In this software development lifecycle, directly or indirectly, directly or indirectly, we can part of this SDLC process. So if you are a developer, can write the lines of code. If you are a tester, can verify the functional. But if you are a DevOps engineer, what exactly you are gonna be do here, please? Let us try to understand what is a DevOps. So first, what is a DevOps? The combination of software development. The combination of software development plus operation, we call as what? DevOps. The software development plus operation We call as what? Software development process. Software development plus operation. We call as what? DevOps. That means what exactly? So as a DevOps engineer, our roles and responsibilities start from dev environment, ends with what? Operation. Means we are part of coding, building, testing, release, deploy, operation, and monitoring. But to be frankly, we are not writing any coding. We are not writing any test cases. Just we are going to be implementing an automated DevOps transparent pipeline. An automated DevOps transparent pipeline. Yes, please. An automated DevOps transparent pipeline. An automated DevOps transparent pipeline. But while implementing our DevOps transparent pipeline, we are following some rules and regulations. Which are all the rules? Which are all the rules we are following, guys, please, within a shortest time, with high quality, with low cost. Let me give an example, then we can understand. So the developers are keep on writing lines of code. These lines of code we're gonna be delivering into the production environment within a shortest time with the high quality, with the low cost is nothing but what exactly our DevOps transparent pipeline. Our DevOps transparent pipeline, guys, please. As a DevOps engineer, what exactly we're gonna be, guys, please, as a DevOps engineer, we're gonna be replacing complex pipeline with what? A transparent pipeline. Replacing with complex pipeline with what? A transparent pipeline. Sir, our SDLC process is a complex pipeline. Our DevOps is a transparent pipeline. Sir, why we are calling SDLC is a complex pipeline? Because of it is a manual process. From analysis to design, design to implementation, implementation to testing, testing to deploy, deploy to maintenance. It is a manual process. Due to this manual process, due to this manual process, due to this manual process, if you got an issue, any problem in middle of the process, if you got an issue, any problem in middle of the process, for identification, it will take long time. For resolving issue also, it will take long time. Due to this issue, definitely the cost will be increased, the quality will be decreased, and customer is not satisfied. For example, to our understanding, I'll give an example. For example, let's say we have a pipeline and is underground. Somewhere else in the water pipeline is underground somewhere else. But blockage is not a leakage, it is a blockage. Can able to identify immediately? No, we can't able to find immediately. We can't able to find immediately. We can't able to find immediately. So for identification, it will take time. For resolving issues, it will take time. But in meanwhile, our customers are not satisfying. The same way here also, if you got an issue, any problem, for identification, it will take long time. For resolving issues also it will take long time. That means the cost will be increased, the quality will be decreased, and customer is not satisfied. That is the reason we are gonna be replacing with DevOps transparent pipeline. In this DevOps transparent pipeline, everything is transparent, everything is an automated. Everything is transparent, everything is an automated. Due to this an automation, due to this transparent, due to this an automation, due to this transparent. Even though if you got an issue, any problem in middle of the process, easily we can able to identify as soon as possible and we can able to resolve as soon as possible. That means what? Cost is reduced, the quality will be increased, and customer is also satisfied. That is the reason we are always replacing complex pipeline with what? DevOps transparent pipeline. But actual DevOps transparent pipeline is look like this only. This is in exactly our DevOps transparent pipeline. In this DevOps transparent pipeline, in this DevOps transparent pipeline, in this DevOps transparent pipeline, we have several stages and several phases like plan, coding, integration, testing, release, deploy, operations. In this DevOps transparent pipeline, we have a plan, we have a coding, integration, testing, release, deploy, operations. In this DevOps transparent pipeline, our roles and responsibilities start from dev environment, ends with what? Operations. Ends with what? Operation. Means we are part of coding, integration, testing, release, deploy, operation. To be frankly, we are not part of planning. We are not doing any coding. We are not writing any test cases. We are going to be implementing an automated DevOps transparent pipeline from dev environment to operations. Clear? Understood this. Sir, how exactly we can able to implement this? Let us understand step by step. So let us understand the roles and responsibility first. Then how, which are all the tools we're going to be understand, please. So first, are we part of planning? No. We are not part of planning, please. We are not doing any planning. Are we part of coding? Yes, we are part of coding. Yes. But we are not writing any code. How, sir? How exactly? Writing is responsible by the developer, not by me. Either developer, Java developer, .NET, Python, whatever may be, any developer can write the lines of code. Those lines of code we're gonna be maintenance, writing by developer, maintenance by DevOps engine. So once if it is written by developer, these lines of code, these lines of code, we are gonna be integrating continuously, integrating all our developer lines of code. Continuously integrating all our developers lines of code. all are developers lines of code. Once if it is integrate all developer lines of code, whether the developers are writing right functions or not, whether it is functionality working or not, our testers will be verified. We are not writing any test cases. This test case is written by testers. Those test cases just we are going to be integrating. While executing test cases, if we got an error, automatically redirecting back to the developer. A developer has to fix an issue, again integration, again execute. And again, it's going to be integrating back this. And again, we can execute, we got an error. Again, it is redirecting back to the developer. Again, it is fixed integration, again execute. So this loop will be repeated until zero errors. Once if it is zero errors, we are going to be delivering into the release. Once if it is released, once if it is released, from release, and particular maintenance window, we're going to be placing our applications on hundreds of servers. Placing our applications on hundreds of servers, we calling as what deployment. We calling as what deployment. Once if it is deployed and we can access over internet as a website. We are accessing over internet as a website like a Flipkart or Amazon or Book My Show, whatever name. Clear? Perfect. Is it understood very clearly? Understood. What is the DevOps? Any questions, please, up to this point? Okay. So, for example, let's say, so developers are keep on writing. Developers are keep on writing lines of code. As a DevOps engineer, we're gonna be delivering into the production environment within a shortest time with the high quality, with low cost, with low failure rate is nothing but what exactly? Our DevOps transparent pipeline. But while implementing this DevOps transparent pipeline, which are all the tools we are gonna be learning? We are gonna be learning Git, GitHub, Maven, Jenkins, JFrog, SonarQube, Ansible, AWS, Amazon Web Services, Microsoft Azure, Google Cloud, Docker, Kubernetes, Elastic Log Stacks, Kibana, and Grafana, and Terraform. And we'll do one major project in the end. Got it very clearly. So these are all the tools we are gonna be learning, guys, please. These are all the tools we are gonna be learning. Git, GitHub, Maven, Jenkins, JFrog, SonarQube, Ansible, AWS, Microsoft Azure, Google, Docker, Kubernetes, Grafana, Terraform. So these are all the tools we are gonna be using for implementing our DevOps transparent pipeline. How exactly we are going to be, please? So let us understand one by one how we are going to be using these are all the tools in our DevOps process. So let us understand, please. So first, let us understand Git. Git is a version control. Git is a version control. Git is a version control. By using Git, the entire whatever the lines of code which is written by developer, those lines of code we gonna be maintained as a version control in a branch wise in a version file. So whatever the lines of code is written by developer, those lines of code we are gonna be maintaining on version control as a Git. And we're gonna be learning Maven. Maven is a build tool. It is always produce an active factories. It helps to manage dependencies. Maven can also use project management tool. It handle versions and releases. It handle versions and releases. And we're gonna be learning Jenkins. Jenkins is an automation tool. By helping of Jenkins, we can able to do it continuously integration, a continuous delivery working software. Continuous integration, continuous delivery, working software. It helps to automate. It helps to automate. It helps to automate software development, build, test, and deploy or operations. So continuous integration, continuous delivery. Continuous integration, continuous delivery. So, so we are gonna be using Git is a version control. Whatever the lines of code we are maintaining in Git, continuously integrating by helping of Jenkins, and while integrating, we are gonna be an execute task automatically and making working software and continuous delivery. What is the Jenkins guys, please? By using Jenkins, we can able to implement our entire CI/CD process, continuous integration, continuous delivery. Sir, where exactly we gonna be delivering? The delivering is nothing but what release? The release which we can able to maintain by JFrog. The release which we can able to maintain by the JFrog. JFrog is an active factory. It can maintain the entire builds, the stable builds, and we can able to deploy applications on hundreds of servers. But we're gonna be learning SonarQube. What is the SonarQube? SonarQube is an open source tool. It measures an analysis of quality of source code, whether the developers are following standards or not, whether the developers are using right functions or not. It will be analysis and it will be statistics and reports. So by helping of Git, Maven, Jenkins, and JFrog, SonarQube, we can able to implement entire CI/CD process, continuous integration, making working software. One second. Continuous integration, making working software, and continuous delivery. Once if it is successfully delivered, we're going to be deploying our applications on hundreds of servers, placing our applications on hundreds of servers, placing our applications on hundreds of servers, we calling as what? Deployment. How exactly we can able to automate these hundreds of servers? By helping of Ansible. by helping of configuration management. Sir, what is an exactly configuration management? Replacing manual configuration process with an automated process we are calling as what configuration process. Replacing a manual configuration process with an automated process on a hundreds of servers we calling as what configuration management. Replacing a manual configuration process with an automated process on a hundreds of servers. We are calling as what configuration management. But this configuration management is supporting by Ansible. Is configuration management is supporting by Ansible. Ansible is a configuration management. Ansible is a configuration management. Yes, please. By helping of Ansible, we can automate our hundreds of servers. But these hundreds of servers, from where exactly we can able to get it? Either from AWS or Azure or a Google. So we can able to get this infrastructure from any cloud, or else we go for physical environment, virtual environment, or cloud environment, either AWS or Microsoft Azure or Google. On top of this infrastructure, on top of these hundreds of servers, we can able to automate by helping of Ansible. And what about Docker? Not only placing our applications on cloud service, we can able to place our applications on a Docker containers. What is an exactly Docker container case, please? Docker container is an isolated area. Docker container is an isolated area, which you can place our websites very easily with low cost, with high quality. So for example, let's say to our understanding, let me give an example. For example, let's say I want to explain with real-time containers how we are using these containers. How we are using this container. The same way, we can able to use our Docker containers also. Our Docker containers also, please. Clear. So how we are using the same way, Docker containers also we are using. But these containers we can able to use for transportations, like goods, like rice, dal, fish, prawns, kind of thing. But our Docker containers we can able to use for deploying our websites, like a Java application, .NET application, Python application, whatever. Clear. Understood very clearly. Is it clear? Is it understood very clearly? I hope you people are understands very clear. I hope you people are understands very clear. But how exactly? These are all containers we can able to manage by the single ship. One ship can manage all the containers or not. The same way, all our Docker containers we can manage by Kubernetes. Kubernetes is an orchestration tool. By helping of Kubernetes, we can manage all our Docker containers. And we're going to be learning Elk, Elastic, Logstash, Kibana. By helping of Elk, after successfully deploying, after successfully accessing, whether this whether this application is working or not, how exactly the performance, we are gonna be monitoring by using application monitoring like Elk or Nexus. But we're gonna be learning Grafana also for monitoring our application or service monitoring. And we're gonna be learning Terraform. Terraform is a cross cloud platform. By helping of Terraform, we can able to automate our infrastructures. So we can create a Terraform file as an ISE infrastructure as a code instead of doing manually. We can able to do it by helping of ISE infrastructure as a code. We can automate either by AWS or Azure or a Google. Terraform is a cross cloud platform. By helping of by helping of these are all the tools we are gonna be implementing an automated DevOps transparent pipeline. An automated DevOps transparent pipeline, please. Any questions, please, all of you? So what we are gonna be discussing, what we are gonna be implementing, I hope you people are understands very clearly. Clear? Any questions, please, all of you? Up to this point, do you have any questions? Any questions, please? Any questions? Fine. That's it, guys, please, for today. So tomorrow we'll discuss about what is multi-cloud, what is the difference between, what is the relation between DevOps and cloud, what is the multi-cloud, what is AWS, what is Azure. We'll discuss by tomorrow. Then day after tomorrow onwards, we're going to be start our regular classes. That's it for today, guys. Please, will be continue by tomorrow. Same time, same link. Thank you.